From our discussion of variation in this context, we can then define an important term called the coefficient of determination, which feels appropriate for being the penultimate thing we're going to learn in this semester, and also always makes me feel like I just found a piece of cheese in Undertale. But before I get into what it is, I do want to apologize in advance, because there's a very good chance I will at some point accidentally call it the coefficient of variation, which is a very different thing from earlier on in the semester, but because the word variation comes up so much in this context, it's just a natural stumbling block for me. Anyway, when we're looking at the coefficient of determination, what we're looking at is essentially the percentage of variation that our model handles, that our model accounts for. That is, our value here, r squared, is the ratio of the explained variation to the total variation. It is explained over total. And for the record, there is another term attached to this called the coefficient of non-determination, which for reasons that I don't fully understand, don't come up quite as much in this book as they did in the previous textbook we used to use. It's a complement there. That would be the ratio of unexplained to total, and it's useful, kind of worth knowing, but we don't really look at it here for, again, reasons I don't understand. Anyway, looking at that, r squared should make you think of things from 9.1, because we used r there, and if there was a sense of justice in the world, it would be the same r, and for once in math, I'm sure it feels like for you guys, because you probably are used to math feeling very unfair, there actually is a sense of justice, because that is the same r as the correlation coefficient. So, if you ever need the value for the coefficient of determination, you ever need that specific value there, instead of having to go through finding all of those variations bit by bit, you can actually just take the value of r and square it. And that will get you your coefficient of determination. But for an understanding of what sort of things we're looking at here, for an understanding of the sort of things that we can use this for, as well as how to compute it, we're going to return to that GDP data again. So for the GDP data, we had that the value r was about 0.874, and we want to find the coefficient of determination and interpret it in terms of explained and unexplained variation. Here, like I said, if you want to, you can go to the trouble of getting r squared manually, and you'd have to do that if you weren't given r, where I wouldn't recommend doing the sums by hand. I would recommend using the calculator. The linear regression functions can give you r squared along with r, but in this case we're assuming we have r to begin with. So if we want to get r squared, we want to get the coefficient of determination, well, actually as easy as hopefully it looks. You take that value of 0.874 that we got for the correlation coefficient before, square it, and you will get that the value for r squared is 0.764, which says that approximately 76.4% of the variation in CO2 emissions, which I'm going to abbreviate as var in CO2. That's not a C, that's a 6. In CO2 is explained by variation in our input variable, which in this case is also not a 6. That should be a GDP. Who knows? As a result, because 76.4% is explained by our model, that means approximately 26.4% is not explained. And this is what we'd be looking at with a thing called the coefficient of non-determination, but we're not focusing so much on that as we are determination. Anyway, from here, we're going to take this another step further, talking more about what we can get for these errors, for these differences, for this variation, in terms of a thing called the standard error of the estimate.